This is our advanced microcontroller assignment SPI in MSP 430. So this is the block diagram of two different MSP 430s, one acting as a master and the other acting as a slave. So the master synchronizes the clock for both the devices. So we can see that the arrow goes from the master device to the slave device, and the MOSI pin means master out, slave in. So since the master is the one sending the message, this pin goes from master to the slave. So the pin on the other side is master out, slave in. So the slave in takes the input from the master, and similarly the pin MISO means master in, slave out. So the slave sends the output from that pin and master receives the input from the same pin, and SS bar is connected from the master to the slave. So yeah, from the logic we can see that the master can communicate with the slave and vice versa, and they can read and write with one another. And SCLK, which the master controls, is the main clock synchronizing both the devices, and SSL is the currently active slave, like if multiple slaves are connected to the master. And MSP 430 has two SPI interfaces, so it can communicate with two slaves at the same time.
Okay, now we shall see how we can set up an SPI on MSP 430. Well, as we know that there is a USCI, that is Universal Serial Communication Interface, and it has the ability to output via the SPI UART, which is enhanced UART. So like we have to configure the pins. As you can see in the diagram, we have configured P1 out to be bit 5, like we are adding it. So we are adding the existing value, we are going to do it, and P1 DIR is also done the same, we are going to add it to bit 5. Now then we are assigning P1 select to bit 1, bit 2 and bit 4, we are pipelining it, and same for P1 select 2. So P1 cell and P1 cell 2, these are two registers which can be used to select the mode, like we can either choose UART or SPI. And coming to the final one, we must set up the UCS ETL registers, and this will tell the microcontroller to use the SPI interface. So as we can see how it is configured in the block, and the microcontroller is thus set to master by setting the UCMST bit. So we then set it to the most significant bit by setting the UCMSB. UC sync is the bit that sets the universal communication interface to SPI mode.
Now a source clock is also to be set up. To do so, we need to set a desired bit by setting up the UCA 0BR0 pin. So from the previous slide, we have seen that here that the UCA CTL pin is selected to UCD WRSG pin. What does this pin do is it will set the module in reset mode so that the normal operations can take place. After everything happens, after the communication happens, we need to set it up to the again negation of UCS WRSG pin. And now in this slide, as we can see that there are TX flag and TX buffer here. What this TXI flag do is when the transmitter flag is up, it won't set or send the data. It will wait for the transistor flag to go down, and then it will load the data in the transistor buffer. And now when the transmitter buffer is empty, and now the receiver flag is updating itself. While the receiver flag is updating itself, it won't receive a data, or it won't process the data further. When the receiver flag is down, it will receive the data and send it to further module. Here is a while loop here waiting for the transmitter flag to go down. Till the transmitter flag is up, it means that the buffer is still filling and it won't go down. And while here the receiver, it will wait for the same case like it did in the transmitter side. Thank you.